Hi friends, welcome back to the video. So today I'll be explaining physics October-November 2013 paper 62. Question 1 states IGCSE classes investigating pendulums. The apparatus is shown in figure 1.1 and 1.2. In figure 1.1 the bob is at resting position and in figure 1.2 the bob is doing complete oscillations. Part A, Part 1 states on figure 1.1 measure the length L of the pendulum. So we will use the ruler to measure the length from here till the center of the bob, which is a dotted line, and that will be 2.95 centimeter. Part 2 states the pendulum is drawn 1/10 of actual size. Write the actual length of the pendulum in the first row of table 1.1. So here in table 1.1 first row we will write 2.95 centimeter in 1/10 of actual size. So this is 1/10 of actual size. So we will multiply this length by 10. So this will be 29.5 centimeter. Then part B states a student displaces the pendulum bob slightly and releases it so that it swings. Figure 1.2 shows one complete oscillation of the pendulum bob. The student uses a stopwatch to record the time t for 20 complete oscillations of the pendulum. The reading is recorded in the table. Part A states calculate the pendulum t of the pendulum. Period t of the pendulum. The period is the time for one complete oscillation. Record the value of t in table 1.1. Complete a column in the table. So over here, first we have to record the value of t in table 1.1 for here it's in the period is the time for one complete oscillation. So the time will be 1.12 because we divided 22.4 divided by 29.5. So this will be 1.12. Then we will complete the column headings in the table, which is t, time will be in seconds, and capital T, this will be total seconds, which is s. Both will be s. This is how we will do. Part C states the student adjusts the length of the pendulum until its length is L is equal to 61.9 centimeter. He repeats the procedure in B and calculates the T. The results are shown in table 1.1. The student suggested that doubling the length L of the pendulum should create double the time period. State whether the result supports this suggestion and justify your answer by reference to the results. So the statement will be no, it doesn't support this suggestion because it is beyond the limits of experimental accuracy. Why? Because if we increase the length from 29.5 centimeter till 61.9, so this will not double the time of the pendulum. So that's why it's no, it doesn't support the suggestion, and justification is because it is beyond the limits of experimental accuracy. D states the student repeats the procedure in B 4 more times with different lengths of pendulum. The student plots a graph of L against T squared. State two pieces of information from the graph that would indicate that L is directly proportionate to T squared. First is if it passes through the origin, and second is if it has a positive straight line gradient. So these are two pieces of information from the graph that would indicate that L is directly proportional to T squared. Then part E states the student uses another pendulum. This pendulum has a mass that is double the mass of first pendulum. Its length is 61.9 centimeter. The period t is 1.61 second. So just a conclusion about the effect of doubling the mass of the pendulum. There is no effect on doubling the mass. T does not depend on the mass. So that's why there's no effect on doubling the mass of the pendulum. So this will be the final answer. Question 2 states the IGCSE class is investigating the cooling of water. A student cools some water by 4 different methods. Experiment A is cooling with stirring. Part A states the student pours approximately 200 cm cube of hot water into a beaker. She measures the temperature. Coaster 1, figure 2.1 shows thermometer. Write down the thermometer coaster 1 shown on thermometer in figure 2.1. So if we look closely, it will be 75, 76, 77 and 78 degrees Celsius. So coaster 1 will be 78 degrees Celsius. If you write 76, 77 or 79, that will be wrong. Then part B states the student stirs the water for 1 minute. She then records the temperature coaster 2 of the water. So part 1 states write down the temperature coaster 2 shown on the thermometer in figure 2.2. So if we again read from the thermometer, this will be 67, 68, 69. So 69 degrees Celsius. Part 2 states calculate the temperature difference between coaster 1 and coaster 2. So coaster 1 is 78 degrees Celsius and coaster 2 is 69. So 78 minus 69 will be 9 degrees Celsius. So this is the temperature difference. Then experiment B states cooling with pouring. The student starts again with approximately 200 centimeter cube of hot water at the same initial temperature coaster 1. She carefully pours the water from the beaker into another beaker. She pours the water back into the first beaker. She repeats this process 4 times. She measures the temperature coaster 3 of the water. Figure 2.3 shows this temperature. So this is the thermometer shown in figure 2.3. Question C part 1 states write down the temperature coaster 3 shown on the thermometer in figure 2.3. So on the thermometer it states 61 degrees Celsius. So coaster 3 will be 61 degrees Celsius. Part 2 states calculate the temperature difference between coaster 1 and coaster 3. So the coaster 1 degree value is 78 degrees and coaster 3 is 61 degrees. So 78 minus 61 will be 17 degrees Celsius. So this will be the temperature difference. Experiment C is cooling with lid and experiment D is cooling without lid. The student pours approximately 200 centimeter cube of hot water into each of the 2 beakers. The initial temperature of the water in each beaker is coaster 1. She places a lid on one of the beakers. She allows both beakers cool for 5 minutes. At the end of the cooling period, she calculates the temperature difference, which is temperature difference of C with lid is 11 degrees and temperature difference of D without a lid is 31 degrees. Rank the experiments A, B, C, D in order with the one that produced the greatest temperature drop first. So in experiment 1, there was a difference of 9 degrees. Then experiment 2 or B has a temperature difference of 17, then C with 11 and D with 31. So first will be D, then B with 17 and third will be experiment C with 11 and last will be experiment A, which has 9 degrees Celsius of temperature difference. Part E states if this laboratory investigation is to be repeated many times to check the results, suggest 2 conditions that should be kept constant in order to provide reliable results. First is the volume of hot water and second is the starting temperature. Part F states a student complains that the investigation is not a fair comparison. Suggest one way in which the investigation should be more fair. There should be same time of cooling for each experiment. So this is how we can make the investigation more fair. Question 3 states the IGCSE class is investigating the resistance of a wire. The circuit used is shown in figure 3.1. So this is the circuit in figure 3.1. Part A states the student places the sliding contact C on the resistance wire AB at distance x from A, where x is 0.2 meters. He measures the current I in the wire. Figure 3.2 shows the ammeter. So this is the ammeter shown in figure 3.2. Record the value of I. I is equal to 0.3 amps. So this is how, because it's directly in the middle between 0.2 and 0.4. So this will be 0.3 amps. Part 2 states the student measures the potential difference V across the wire between A and C. Figure 3.3 shows the voltmeter. So this is the voltmeter, and the reading on voltmeter is at 0.4. So part 3 states calculate the resistance R of the section A of the wire using the equation R is equal to V divided by I. Record R in the first row of the table 3.1. So the value of V, which voltage at 0.2, is 0.3 volts. Then the resistance is 1.3, which we have calculated. Then here we have other values of 0.35, then 0.5 distance of x, and then 0.65 and 0.8. So part B states the student records the voltmeter readings using a range of x values. The readings are shown in table 3.1. Plot a graph of R ohms y-axis against x meters at the x-axis. So here we have written R ohm resistance and x meters on the x-axis. Then we have plotted the graph, which is a straight line. So this is how we will draw the line or the graph in question B. Question C states, using your graph, determine the length L of the resistance Y necessary to make a resistor of resistance 1.2 ohms. Clearly show on your graph how you obtained the necessary information. So on the graph over here, at 1.8 ohms, over here we will measure the length, which will be around 0.18 meters. So the length will be 0.18 meters. Then D states, predict the resistance Z of 1.5 meter of resistance wire. Show your working. So at 1.2 meter it is 0.8, 1.2 ohm it is 0.8 meters. Then at X, what will be the length, what will be the resistance if the length will be 1.5? So we will multiply 1.5 into 1.2 divided by 0.18, which will be 10 ohms. So the resistance of Z of 1.5 meter will be 10 ohms. So this is how we will calculate the resistance at 1.5 meters. Question 4 states the IGCSE class is determining the focal length of a converging lens. Figure 4.1 shows the apparatus. Part A states, on figure 4.1, measure and record the distance u in millimeters between the illuminated object and the lens. So the length from after this leaf or this object will be measured up till this dotted line, which will be 24 millimeter or 2.4 centimeter, but we have to convert 2.4 centimeter into millimeter, so this will be 24 millimeter. Then part 2 states, measure and record the distance V in millimeter from the center of the lens to the image on the screen, which is V is equal to, so this will be the length from here dotted line till the starting of the screen, which will be 4 centimeters. Then we will convert it into millimeter, which will be 40 millimeter. Then calculate the value of UV. So 40 into 24 will be 96 millimeters squared. Then part 4 states calculate the value of u plus v. So 40 plus 24 will be 64 millimeter. Part V states calculate the value of f1 for the focal length of the lens using the equation which is f1 is equal to uv divided by u plus v. So the value of uv is 960 and value of u plus v is 64. So 960 divided by 64, which will be 15 millimeter. So the focal length f1 will be 15 millimeter. Part 2 state or question B states a student suggests not to move the position of the screen or the illuminated object. She moves the lens towards the screen until a smaller, sharply focused image of the object is seen on the screen. The new values of the u and v are u is 42 millimeter and v is 25 millimeter. Then part 1 states calculate the value of uv. So 42 multiplied by 25, which will be 1050 millimeter squared. And part 2 states calculate the value of u plus v, which will be 42 plus 25. So this will be 67 millimeter. Then part 3 states calculate a second value f2 for the focal length of the lens using the same equation that we used in f1. So uv divided by u plus v. So uv was 1050 divided by u plus v, which was 67. So 1050 divided by 67, which will be 15.7 millimeter, which is the focal length f2 of the lens. Then part C states a student suggests that f1 should be equal to f2. State whether the results support this suggestion. Justify your answer by reference to the results. So f1 was 15.0 millimeter and f2 is 15.7 millimeter. So the statement is correct, and because it is within the limits of experimental accuracy. Why? Because it's not more than 1 millimeter difference, it's less than 1 millimeter difference, so this is acceptable. Part D states, state 2 precautions that you could take in this experiment to obtain more reliable results. So part 1 is the height of the object and lens should be of the same height. Measure the length from the center of the lens, not from the edge of the lens. Then part E states the illuminated object is triangular as shown in figure 4.2. Sketch the image that you would see on the screen. So this will be on the opposite side of this, equal length from both sides and equal length from here till here, which will be the same over here from here till here. So this length should be same with this length, and this both lengths should be same with this length. So this is how we will draw the image of the triangle on the screen. Question 5 states the IGCSE class is investigating pressure. A student places a rectangular block on a sheet of paper on the bench and draws the outline. Figure 5.1 shows the outline. So this is the outline in figure 5.1. Part 1 states on figure 5.1 measure the length x of the block. So we will use the ruler to measure the length from this line till this line, which will be 6.7 centimeter. Part 2 states on figure 5.1 measure the width y of the block. So we measure the length of y using the ruler from this line till this line, which will be 3.2 centimeter. Question B states figure 5.2 shows the block being weighed using a force meter. Using figure 5.2, write down the weight W of the block. So the weight of the block using the force meter over here, this should be given first, but so over here it is from up till down, not from down till up. So 1, 2, 3, 4, 5, 6, and then between 6 and 7, it's in halfway, so this will be considered 6.5 Newton. So the weight will be 6.5 newtons. Part 2 states calculate the pressure P that the block exerts on the bench. Use the equation where P is equal to weight divided by area, where A is the area of the block in contact with the bench, which is A is equal to X multiplied by Y. So P pressure is equal to weight, which is 6.5 newtons divided by area, which we calculated over here. Length is 6.7 and width is 3.2. So 6.7 or 6.65 more accurately multiplied by 3.15 or 3.2 is equal to, which will be 0.31 pascals, which is wrong. We should not use pascal. It is in, the pressure is measured in 0.31 newtons per centimeter cube, because this is newtons and this is centimeter cubed. So we will use newtons per centimeter cubed square. Then part C states the value calculated for P is slightly too small. Suggest one practical source of inaccuracy that would account for this. The length of the block is not read perpendicularly to avoid parallax error. So you need to read the length of the block perpendicularly to avoid the parallax error. Then second is surface area of the block is increased slightly due to the thickness of the pencil line drawn. So the surface area of the block is also increased slightly due to the thickness of the pencil line drawn. So this is two source of inaccuracy that would account for this. So this is how we can reduce the inaccuracy of calculating the pressure. Thanks for watching this video, and don't forget to like, subscribe and share this video with your friends and family, and I will be uploading another video soon. Thank you. Bye.